What's poppin', dogs? Mr. Allen here with a video on systems of equations. But these aren't your everyday systems of equations here. We got ourselves a quadratic in here, and in that one right there. So we have a linear and a quadratic. So it's a little bit different than your normal, two linear equations, how you approach that. But we have some similarities as well. So let's get after it. First example here. I've got 2x plus y equals 15, and then I have y equals x squared. I'm not going to really set up like an elimination method here. I'm actually going to use substitution though, because I know that y equals x squared. Why don't I just substitute in x squared in place of that y, and then I have an equation with just x's. Check it out. I've got 2x plus x squared equals 15. All right. That's just going to be a trinomial if I set that equal to 0, right? And I can hopefully use factoring to solve. So let's rearrange some things. I'm going to put the x squared first, the 2x second. I'm going to subtract 15 on each side, and now it's equal to 0. So we're going to use factoring or quadratic formula if it doesn't factor. But does anything multiply to negative 15 and add to 2? Yes. X plus 5 and then x minus 3 equals 0. I almost wrote the 5 first. Well, I did start writing the 5 first. All right, there we go. So 5 and negative 3 multiplies to negative 15, adds to positive 2. Now I can set these two equal to 0. X plus 5 equals 0, and x minus 3 equals 0. So if I subtract 5, I get x equals negative 5. Add 3, I get x equals positive 3. But here's the thing. That's not just my answer, okay? A system is on a graph, right? So we could graph each one of these. So I'm going to have a straight line and a curved line, like a quadratic, right? A parabola that's opening up. And then I'd have some other kind of, looks like negatively sloped line. I'm going to have two different solutions. So my solutions are actually these 2 points, meaning I need an ordered pair for my solutions, okay? So for this one here, I'm going to pick either one of these two to figure out my y coordinate that goes with it. Whichever one's easier, it's going to give you the same exact answer, okay? I'm going to choose y equals x squared. So if I have y equals negative 5 squared, I get y equals 25. So one of my answers is negative 5, comma, 25. Cool? And I'll do that again over here. That seems like the easiest one to do. So I got 3 squared, so y equals 9. The other ordered pair is going to be 3, comma, 9. So those are my two solutions for that system. Okay, you got to get the ordered pair there. Unless I've seen on like the SAT where they just ask for what's the positive x coordinate that would satisfy this system. 3 would have been the answer for that one, right? So if they had like a free response thing, they might just ask for that. You get negative 5 and 3. 3 would be your answer there. But if you're asked for the actual solution here, it would be 2 ordered pairs for this particular one here. All right, let's do the next example, shall we? We shall. Okay. So here, it won't necessarily look like substitution, but it is substitution. These are both equal to y, right? So I can set them equal to each other. So I could essentially substitute x minus 5 in for y, or I could substitute x squared plus 7x in for this y. I'm going to do the second option there because then I have my x squared on the left-hand side, and I just like that. It makes me feel warm and fuzzy. Okay, there we go. Now I have a quadratic. I'm not going to use square roots here because I have a squared term and I have a linear term. I have a quadratic and a linear term. Let's set it equal to 0. See if we can factor this thing. And if not, we'll have to use quadratic formula. Okay. So I subtracted x to get 6x. I added 5 to both sides, so we got plus 5. Does anything multiply to 5 and add to 6? Heck yeah, it does. X plus 5, x plus 1. That's going to multiply to 5 and add to 6. Now I'll set them equal to 0 as I just did. And then subtract 5, so I get x equals negative 5, and I get x equals negative 1. Hopefully you guys are okay with me, like not showing the minus 5. We got a lot of work to do here, so I want to save some space. And if we're starting to deal with these here, we should get comfortable maybe being able to skip a little bit of the notation there so that you have enough time to finish out the rest of the problem. So as we know, our answers should be like negative 5 comma something, negative 1 comma something. I might even suggest jotting that down on the answer line once you get to this point so you remind yourself to get the next one, or put ordered pairs on your answer line so you remember, I got to have an ordered pair. It's a system of equations here. All right, so how are we going to get that? We're going to plug it into one of these two. I think the second option is probably the easiest. I'm going to have y equals negative 5 minus 5. That's negative 10. So negative 10 goes here. And then I have y equals negative 1 minus 5. That's going to be negative 6. So negative 6 goes here. Once again, we have 2 solutions, 2 ordered pairs. There we go. Boom. Diggity. That's dope, man. System's a little bit scary, but it kind of just sets up like a factoring problem. Could be a quadratic one, but that would be absolutely terrible. We'd probably use our calculator and just use the decimals to plug back in if it didn't work out very nice. But it can, right? You can also get no solution, or you could even get 1 solution. These both had 2 solutions here. That's awesome, dope. Radical. See you dogs later.